So we have a question. Suppose that there is some charges which are distributed along the x-axis in one dimension in minus a to plus a region. The charge density is defined in that region and which has some value rho x prime and it is 0 otherwise. So it has been asked to find out the potential in terms of the charge density, and in second bit it has been asked to find out the multiple expansion for this type of potential when x is greater than a. Let us do this. First of all, let's say this is my origin, this is minus a and this is plus a, and this is the region where the charge density is present. Plus a region charge density is present in this region a, and in this region the charge density is rho x prime. Remaining the region charge density is 0. Let's say I consider a length element at a distance of x prime from the origin. The length element is dx prime. Let's say my x is a distance from the origin where I have to find out the potential. Let's say this is the point P. Then with respect to the length element, my distance will be x minus x prime. The electric potential due to the length element will be dq upon 4 pi epsilon naught r, and here dq will be rho x prime dx prime, rho x prime dx prime, and 4 pi epsilon naught, and r is the distance which will x minus x prime. So r है वो x minus x prime होगा, और now phi will be the integration of d phi is equal to rho x prime dx prime 4 pi epsilon naught x minus x prime integration, where x prime varies from minus a to plus a. This is the potential in terms of rho x prime, and then it has been asked to derive the multiple expansion. uh, Now for the potential, now I have the, so I have been left with uh, d phi is equal to integration minus over to plus a 1 upon 4 pi epsilon naught uh, rho x prime dx prime upon x minus x prime. As we know x is greater than a, क्योंकि यही रीजन है जिसमें हमें मल्टीपल एक्सपेंशन ढूंढना है, and x prime is less than a, so I can write x minus x prime is greater than 0. So that term 1 minus x prime, it can be expand in terms of Taylor series as follows. I can take x is common from here, so I remain with 1 minus x prime over x, 1 minus x prime over x, which will be 1 by x and 1 minus x prime over x to the power minus 1. Now x prime over x always less than 0 because x is greater than x prime. So we know that Taylor series of 1 minus x to the power minus 1 or 1 minus a to the power minus 1 is equal to 1 plus a square plus a cube plus so on. So this will be 1 over x, and this टेलर सीरीज एक्सपेंशन अगर हम इस तरह से कंपेयर करें तो ये आ जाएगा 1 प्लस एक्स प्राइम ओवर एक्स प्लस एक्स प्राइम ओवर एक्स होल स्क्वायर प्लस so on, and this will just remain 1 over x plus, and this will be x prime over x square plus x prime square over x cube plus so on. So putting this value in this integral, I get phi is equal to integration minus over to plus a 1 over 4 pi epsilon naught rho x prime upon x dx prime plus rho x prime x prime over x square dx prime plus so on. And this is the multiple expansion, and where this term is correspond to monopole and this term is corresponding to dipole terms. Next, I have a question that a ring of radius r and charge q uniformly distributed over it. Consider a charge minus q constant to slide along axis of ring so that it execute SHM. So we have a ring. So we have a ring of charge q, sorry, which distributed over its circumference. तो जो चार्ज क्यू है इसके सर्कमफेरेंस के ऊपर डिस्ट्रीब्यूट हो रहा है, तो चार्ज डेंसिटी लेट्स से लैम्बडा इज इक्वल टू क्यू अपॉन 2 pi r. I defined somehow charge density, and it has radius is somehow r. It has been asked to find out the electric field. It has been asked to show that the charge minus q, if I put a minus q charge to slide on its axis, it will be do SHM. How? However, you know that for a ring, if a positive charge is distributed over its circumference, the electric field is along the axial direction in the, अगर हम चार्ज पॉजिटिव चार्ज को डिस्ट्रीब्यूट करें तो जो इलेक्ट्रिक फील्ड होगा यानी एक्सियल पॉइंट में वो सिर्फ एक्सियल लाइन के डायरेक्शन में होगा. तो इसका मतलब माइनस क्यू एक चार्ज आ रहा है तो इसको अट्रैक्ट करेगा और बीच में इलेक्ट्रिक फील्ड जो जीरो है और इसके बाद वो इधर से अट्रैक्ट करेगा. तो पहले इधर जाएगा फिर यहाँ पे जीरो हो जाएगा फिर इधर जाएगा तो वो एसएचएम करेगा. तो इसको हमें शो करना है. Due to symmetry, at center electric field is equal to 0. At the center electric field is always 0 due to symmetry, and at any point P electric field can be easily find out. Let's say this is the line element having charge dq, and if I take corresponding line element from the opposite side having charge same charge dq, then from the symmetry the vertical component will be cancelled each other and I am left with the horizontal component. So effective field is due to this horizontal component. Let's say this makes an angle theta, and this is somehow r distance apart, radius is r. This will be r square plus r square under root. And electric field will be dq over 4 pi epsilon naught r square plus r square, and only the virtual component, the horizontal component will be there and the vertical component will be cancelled out. So effective field due to horizontal component dq 4 pi epsilon naught r square plus r square to cos theta, and dq will be somehow lambda dl or 4 pi epsilon naught r square plus r square cos theta integration, or I can write cos theta, and cos theta will be, from this figure cos theta will be r upon r square plus r square under root, sorry, r upon r square plus r square under root. So I can put that. So E is equal to lambda dl 4 pi epsilon naught r square plus r square to the power 3 by 2, and there will be r on the numerator integration, and the here r is constant with respect to the dl. 4 pi epsilon naught is constant, this term will be constant, so everything is got outside the integration, and we know that the integration of lambda dl, which is equal to total charge, which is q. So I can found electric field is equal to q over 4 pi epsilon naught r square plus r square to the power 3 by 2 into r. This is the expression for electric field at any point on the axis. And now I have electric field. Let this point is r. So if I take a charge minus q, then force is equal to E into minus q, which will equal to minus q square r divided by 4 pi epsilon naught r square plus r square to the power 3 by 2. And similarly, this will be electric field will be always outer direction, so this will be along, let's say this is z, this is z axis, so this is z, so it will be z axis. So at this point the force is along minus z axis, at center the force will be 0, and again in the negative side the force will be along positive z axis, so it will be oscillate. And another thing is that if we do something such that the radius is much larger than the distance, then the in this term the r square term will be dominant. The force will be minus q square r where 4 pi epsilon naught rq, and this is in the format of f is equal to minus kz. So this shows that if in this condition the particle will do SHM, the minus q charge will do SHM with frequency k is equal to q square upon 4 pi epsilon naught rq, and I can find out frequency as frequency is equal to k by omega root over, so it will be q square upon 4 pi epsilon naught rq m root over. With this frequency and under this condition the particle will do simple harmonic motion.